How is everybody doing today? I hope you're doing well. Today we got 2.1 to 2.2 linear graphing notes. We're not going to get through the whole thing. It's going to be split into multiple parts. But this is going to teach you the basics of the coordinate plane, how to graph, and essentially this video is going to assume that you have no incoming knowledge of this. So we're going to start from scratch and we're going to build up from there. Let's go ahead and get started. So this thing right here that we got drawn, okay, it looks kind of like a mess, but it's just got some pre-labeled points. This is the coordinate plane. It's a plane of two different axes, a vertical axis. Okay, let me just get some blue here. This is a vertical axis, and we call this the y-axis. Okay, and then we have a horizontal axis, or horizontal axis because it's singular. Okay, let me highlight it right here. This is the horizontal one, okay, and this is known as the x-axis. Now, the reason why you need two, it's kind of like a location on a map. You need two coordinates. If you just have one, it's only up and down. Okay, so you have up and down, left and right. The x commands the left and right, and the y commands the up and down. All right, so we have coordinates here. Now, what we need to kind of figure out is how do we label these points? Well, each one of these locations that you see here in yellow with these red dots, these are different ordered pairs. What do I mean by that? Well, in order to find the exact location, we need to have an x coordinate and a y coordinate, a horizontal left and right coordinate, and a vertical up and down coordinate. Now, when we're talking about the different locations here, you can kind of see that there's a natural split between different zones. What do I mean by that? Well, you can see it, there's this top right little corner here, this top right box. You have this one on the left over here. Okay, you have one on the bottom left over here and there. These are called quadrants. As you can probably guess, quad stands for four, and there's four sections, so they're quadrants. Now, what are the quadrant numbers? Well, the quadrant numbers go in counterclockwise fashion, and they are 1, 2, 1, 2, 3, and then 1, 2, 3, 4, and they use Roman numerals. So 1, 2, 3, 4. Don't think that that's I, and then IV. Okay, that's 1, 2, 3, 4. Now, based on the location of the quadrants, you'll notice some patterns about the x and y coordinates. For example, in the first quadrant, the y coordinate is positive and the x coordinate is positive. Okay, they're both positive. We go in the positive direction is this way. Okay, so if you imagine that, well, we should label this point too. This point is the origin. This is 0, 0. And I think we're going to talk about this later, but this is the origin. Think origin, that's the start. Now, anything to the right is going to be positive. Anything to the left is negative when it comes to the x-axis. Consequentially, anything above, up from the origin is positive. Anything below is negative. So we have our negative and positive directions. And using this, we can label all the points. Okay, so let's go ahead and jump over to coordinate 2. If you want, pause this video, fill it out, and see if you did this correctly, okay? So there's my 3, 2, 1 to pause. All right, I'm going on. So now, in this quadrant to the left, notice how we went to the left. So we went in the negative x direction, so x is negative. But our y is still positive because we went up, so we have a positive y. Now over here, in quadrant 3, notice we went to the left again. But this time we went down, so we have a negative y value for our coordinate. Okay? So again, ordered pair. It's in order of x and y, and there's two of them, a pair. Okay, so that's where an ordered pair comes from. And finally, over here, we went in the positive x direction, but for y, we went down. Oops, this is the wrong one. It's over here. Sorry, I just lost it for a second. Negative y, and then positive x. Now, these other two spots, these are different. Okay, slightly different. Why? Well, these are called intercepts. Why do you think they're called intercepts? Well, they're intercepts because they intercept the axis, or the axes, multiple. This one is an x-intercept because it intercepts the x-axis. And this one is a y-intercept Because it intercepts the y-axis. It's right on the line. That's the only time it can be called an intercept, is it's when it's directly on the line. Now, both of these have special scenarios. Okay, for this one over here, we're going to have some sort of positive x value. It could be over here and be a negative x value, but I'm just talking about in this particular case, we're going to have an x value, but the y value is 0. It's neither positive nor negative. It's right on the line, so it's 0. So anytime we have an x-intercept, we are going to have a 0 y value. On the other hand, we're going to have a y value over here. So in this case, it's positive. It could be down and still be an intercept. But what's the x value? The x value is 0. So for a y-intercept, the x value is 0. Okay, that's very important to understand that. And why it's 0 is because it's right on the line. It's neither to the left, it's neither to the right of the y-axis. It's right on the line, so it's 0. Okay, very important that we understand that. Oh, by the way, this is drawing by one of my former students. Just wanted to shout out to Isabella. If you want to draw something for me and send it over, great. I would happily add that to my notes. Now, so we got the basics of this. We understand that we have two variables here. We have a y, we have an x, and then because of that, we can go up, down, left, right, diagonally, okay, in 2 dimensions. All right, so now, let's go into this example. Each equation with 2 variables includes 2 numbers, 1 for each variable. So we have an equation here, and you'll see that we have an x variable and a y variable. An equation in 2 variables, it's linear because it has no powers of x and y. It's just to the first power. So the question is, how many can you think of? Kind of vague question here, but it's talking about how many values can we put in for x and y to make this a true statement that it equals 6. So what can we put in here? Well, if we put in, for example, if we put in 3 for x, what we'd have to put in for y? Well, let's see. If we put 2 times 3 plus 3 times, we don't know what yet, equals 6. That's 6 plus 3y equals 6. What does y need to equal? We'd have to subtract 6 to find out. We get 3y equals 0. Divide by 3, we get y equals 0. And there's 1. Okay, so there's 1. Are there more? Why, of course there's more. We could put in, instead, we could put in 2 for y. We could say y equals 2. What happens there? If we put in 2 here, then this becomes 6, and we'll need x to equal 0. Now notice how these need to be paired together, okay? You just can't keep them separate and be like, oh, what if we have x is 3, y is 2? No, it doesn't work like that. You have to, if x equals 3, then y equals 0. This becomes an ordered pair. If x equals 0, then y needs to equal 2. This becomes an ordered pair. What happens is, as you write down, well, hold on, how many can you think of? There's an infinite number. So as you continue writing these down, you're going to get tons of points. And what are they going to form? They're going to form a line. Okay? That's why these are called linear equations. What do you notice about the word linear? You see the word line right in there. So let's go ahead and talk about table of ordered pairs, and then we'll save standard form for the second video. I want to keep this video a little bit short. So we have table of ordered pairs here. Okay, what do we do with this? Well, I like to put my x, this is pretty standard practice, is putting the x on the left, the y's on the right. And what we're going to do is we're just going to come up with a table of values here. So we can come up with any value for x that we want. Generally, it's assumed that you are going to use the x as the inputs. So you can come up with any values that you want for x. Okay? And then what we do is we plug these in. We plug in values. So step 1, let me write this out. Choose any values for x. Step 2, plug values or substitute values of x into equation. And then step 3, get y. Okay, I'll get to step 4 in just a second. Get y, step 4. There, we'll get there in just a moment. So what do I mean by that? Well, we can choose any value that we want for x. Now, we should be strategic about which values we should place. So if we look at our coordinate plane here, we see it goes to the left like -10 and to the right +10. So it wouldn't make any sense. Let's choose -200. Why would we do that? It doesn't make any sense to do that. Let's choose smaller numbers to give ourselves a little bit easier of a time. So I'm going to start off really basic here. Oh, notice that this is the same equation, okay? I kind of gave us it away that it's going to be linear. We're going to have a line here, but this is the same equation. Just wanted to give you a heads up on that. Okay, so any values for x. Let's go ahead and choose. What I like to do is I like to choose some negatives, I like to choose 0, and then I like to choose some positives. I like to kind of build it around here and just kind of get an idea of what it's doing. All right, so let's choose some smaller numbers. Let's choose -2 for x. Let's choose -1 for x. Let's choose 0, just like I said, and then 1, 2. That gives us a good sample of what we should choose for y. So step 1, choose any values for x. Be smart about it. Don't be goofy. So we have 2 times, we're going to start with the first one, 2 times -2 plus 3y equals 6. And once you get comfortable doing this, you don't necessarily need to write it out each time. You can kind of do it in your head by plugging it in, but you have to be good at substitution before you can kind of branch off and do that. So now we have -4 plus 3y equals 6. We're going to add 4 to both sides. Ooh, we're going to get a nasty number here. We're going to get a nasty number. So we're going to get 10 equals 3y. We get y equals about 10 divided by 3 is 3.3. So we're going to get 3.3. Not a fan of that. That kind of gives us an indication that we should choose a little bit different numbers for x. Now what happens if I choose -1? So I'm going to replace this with -1 and try this whole process again. -1, so I get -2 plus 3y equals 6. I'm going to add 2. I get 3y equals 8. Yuck. Again, we get some gross numbers. We get 8 divided by 3. Just so you can have an understanding, we're going to get 2.6. About. I'm rounding here just for simplicity's sake. So we have 2.6. Gross. Okay. But we're still getting an idea of what it looks like, okay? I should have chose some better numbers, like in terms of that are divisible by 3. And you can do that too. So if you realize that you're like, oh my gosh, look at these decimals, what we can do is we can just do this. And I want to show that you can make those on-the-fly adjustments. So we're going to adjust this down, okay? Go like this, and we're saying, okay, I didn't like those numbers. Let me go to -3. So I'm going to put in -3 because you notice how we're dividing by 3 each time. I get -6 plus 3y equals 6. I add 6, and I get 3y equals 12. What do you know? This is divisible. I do 12 divided by 3, and I get 4. So I get y equals 4 when I do that. So that's a better number to work with. And then we're going to go to 0, okay? So as you can see, this is kind of a tedious process. We get 3y equals 6, and we get y equals 2. I think we already did that one. Okay, we're going to get some decimals here. So I'm going to go ahead and jump. I'm going to be smart about it. I'm like, hey, I realize that -1 and -2 were not divisible by 3. I'm going to pick something that's divisible by 3. So I'm going to pick 3. And what am I going to get? I'm going to get, well, let's plug it in. Let's find out. Plug in 3 there. So I get 6 plus 3y equals 6. I think we did this one. -6 minus 6. I get 3y equals 0. So y is going to be equal to 0 once we get there. Now, what can I do here? We're on to step 4. We got our y's. Okay, done. Check. We did that. Check, check. Now we're on to step 4. This is where we plot ordered pairs. We have a bunch of ordered pairs here. We have coordinates. Look at these coordinates. We have our x direction and our y direction. Now, surprisingly, even seniors, adults, I've seen this mistake. They get their x's and y's confused. Make sure you label your axes first. Understand that x coordinate is on the left. So if we're going to plot this first point, we're going to go 3 in the x direction. So we go 1, 2, 3. Do not put the point there. We still need to go +4 in the y direction. 1, 2, 3, 4. There's our first point. This one right here. Okay. Now we're going to do -2, 3.3. So we're going to go 1, 2. Okay. Actually, I'm going to erase these. These are ugly. Okay. So let me do this. So I'm going to go 1, 2. Okay. And then I go up 3 and a little bit. So 1, 2, 3 and a little bit. So I'm going to put a dot right there. Okay. So now we have -1 and 2.6. So I go -1. This is -1 in the x direction in relation to the origin. You always start at the origin. So then I go up, how much? 2.6? Yeah. 1, 2.6. So I'm going to go right there. About. Okay, and then 0, 2, this is a special point. Why is this a special point? Well, if I start here and go up 2, I'm still on the y-axis. This is known as our y-intercept. That's our y-intercept. Okay, and then I'm going to skip ahead to 3, 0. This is another interesting point. We go over 1, 2, 3, up 0. This is our x-intercept. Whoops, I meant purple. Let me get a different color. X-intercept. Okay, and then once we get, actually we only need 2 dots really, but I wanted to plot a couple just so you get the idea of it. And once we get our lines, we can kind of see where this line goes. And if we connected all these points, this is what it would look like. Make sure you draw your arrows on the other ends of it so that it shows that it continues. And that's what represents all the possible solutions of this equation. All the values you can plug in for x and y that will make this a true statement equal to 6, okay? That's kind of like your real basic intro. Get ready for part 2. We're going to talk about standard form, and then probably a part 3, we're going to talk about the midpoint formula. Thanks for watching, and tune in for the next episode.